Hey everybody, Lars here. Tonight, real quick, we're going to run through the third review video. I'm going to bring up the animal class that we worked with in the second review video, and we'll run through that stuff again. And then after I do that, we're going to talk about some additional features and some different things we can do with our classes that are part of object-oriented programming. We're going to review a thing called class variables, which, as opposed to instance variables, are variables that run for all of the objects that are created with that particular class. And we're going to see how we inherit from the animal class with cat. And we're going to really quick whip up a class called dog, but we're going to show that all of those different objects can share from one variable, and it's convenient to keep track of how many objects we have, and that's what we're going to do with it. Another thing we're going to look at is a thing called a deconstructor, which is what it sounds like. It's the opposite of a constructor, and it tells you, well, it tells the object what to do when an object is destroyed, and we'll show how to do that. And also, really quick, we're going to talk about function overriding. We're going to override the string function, so we're going to tell our objects what to print when we run a print function on them. All right, so let's get to it. Why not? All right, I brought up our friendly animal class from before. Just by way of review, we create a class. When we create a class, we say class. We're going to define a class. I called an animal, and this is the constructor. The constructor is the method that's run when I take this class and I instantiate it and get a real object that we use in our programs. You can see self here. That's just the name of the variable itself, and Python takes care of that. You don't have to worry about it. And in our class, we bring in two parameters. One is called name, and the other is called weight. And as you can see, we set them in instance variables right down here. So when we create the object, that's what gets run. That is what gets run. I can't talk today. You see right here, I have my getters and my setters so that I can get my variables from my object, and I can also reset them if need be. And then at the bottom, in order for me to demonstrate polymorphism, I created a simple method called speak, and when you run speak on your animal, it prints sound. Okay, but what we did right after that is we wanted to show inheritance, so we created a class called cat. Cat, as you can see right here, inherits from the class animal. So whatever I can do when I create a cat object, whatever I can do with that animal, I can now do with cat as well. But what I did was I added one parameter to the constructor, and I showed that when we inherit from a class, we want to set up that object that we're creating just like we set up the previous class that we're inheriting from. So I run the animal constructor with the parameters it is used to getting. And anything extra that I add, like I added color here, I keep as an instance variable in just the cat class. So as we said before, animal doesn't know anything about color. That's something we completely did with our cat class. And I do a getter and a setter for our new parameter. I incorrectly just wrote return color when we did the example. I don't know if anybody picked up on this when I did the video for the second review. That's incorrect. It should be self.color, and I corrected it before I put the code up in your resource folder, and I corrected here. I'll get rid of this now that we don't really need it. And then the reason I did this speak method up here in animal is to show you an example of polymorphism. I overrode the inherited method and I wrote my own, because now I know I have a cat. So when I ask the cat to speak, it should say meow. And really quick, we are going to create a dog class. This is insanely simple because I'm going to do the same thing with dog that I did with cat, except I'm going to make one change. So watch this. I am just going to copy the cat class. I'm going to come down here, and I'm going to paste. So I have an exact copy of it, only this time I'm just going to come up here. I'm going to call it dog. All right. Everything else is the same because I really don't refer to the class name in it, except when I get down here and I run speak, this is a dog. So I'm going to put bark. I could put woof, I guess, but I'm going to go with bark just for now. So now that simply, I have a dog class, so I can create a dog now. And when you get more sophisticated with your programs and you see things, more examples of object orientation being used, you'll see that this happens a lot. We will create a base class that we just inherit from. We don't really call an animal because it's vague, print sounds, who does that, blah, blah, blah. But when we create our more specific classes, we'll always inherit from that base class. If you have a class that you know you're never going to instantiate and you're just going to use it for inheritance purposes, we call that an abstract class. But we're not going to get that complicated and we're not going to get into it. I just want you to be exposed to the term in case you see it or hear it someplace else. So, boom, that's simply, I created a dog class. It's going to do all the same things that my cat does, except I redid the speak method so that my dog will say bark. Let's go test that theory. I'm going to create a variable called C1. I will say cat. I will keep the name Felix. Felix will weigh the same. Felix, if memory serves, was brown. All right, so we got that. Now I'm going to say D1 equals dog. What's a good dog name? We'll go Fido. We'll say that Fido is 30 pounds, medium sized, I guess. And we'll say that Fido's color is, I don't want to make him brown too. We'll say red. Maybe Fido is an Irish setter. Okay, so now we have these two objects ready to use. I can say print. I don't have to say print. I can say D1, speak, and I can say C1, speak. And when I run this, I see bark and meow. Because when I ask my dog object to speak, my dog says bark. And when I ask my cat object to speak, my cat says meow. And that is an example of polymorphism because I'm running the same method name on both objects, but they do different things. They have many forms. Okay? So that's kind of a real quick lightning review of all the stuff we've done so far. Class creation, constructors, the getters and the setters. And then we looked at inheritance and polymorphism. Inheritance being where I can tell the dog class I want to do everything I can do with animal. I call animal's constructor to set it up the same way it originally was. Then I add anything new that I may have added, in this case color. I do getters and setters for my new parameter. And then if I want to override any methods that need to work in a particular way for my new class, I would do that. And as you can see, animal has a speak method that says sound, but my cat says meow and my dog says bark. Okay? So here we have it. We've got 3 classes, and as I always do, I will stick this code up in your resources so you can look at it after you watch this video, or even during. And you see the animal class, you see the cat class, and you see the dog class. Now, we're going to discuss some new features and some new things that you can do with object orientation. And the first thing I'm going to tackle is something called a class variable. When we create our objects, we have in our constructor a way to set the parameters that come in with instance variables. Now, when I get an animal object, I will give it the name, in the past Fred, and the weight 200. Those variables are instance variables. They are only for the object that is created with this class when we instantiate it. So that's it. If we create another object, that other object can't see those variables. They're instance variables. They pertain to the object itself. What if we wanted something different? What if we wanted a variable that every object created with this particular class could see and use? Would that be convenient in some sense? And we're going to show you one. And in this case, what we're going to use it for is to keep track of how many objects have been created with this class. So let's say I wanted to call it animal count. I will define my new variable here outside of the methods for the class. And I usually do it right underneath the class declaration. And I'm just going to say, do I want to? I'll just call it account. I will say account equals 0. So now I've got a variable right underneath the class declaration that says account equals 0. So what do I want to do with account? I want account to be a variable that keeps track of how many objects I have. So almost like a counter, which is what it is, account. I want to click it every time I create something. Okay. What do I do when I create something? I run the constructor. So I'm going to add a line to my constructor. And that line is just going to be account plus equals 1. So I will click that by 1. But there's a trick here. And the trick is this. If I just said account and we ran this, it would blow up because it doesn't know what account is. Account isn't an instance variable. So whenever something is alone, it thinks it was a parameter that was passed in. There's no self in front of it. There's no anything in front of it. So it doesn't know what account is. As a matter of fact, let's run it. And I'm betting it'll explode. Let's see. Animal. We'll go with our old animal, Fred, old fat Fred. Fat Fred is 200 pounds. Oh, Fred. And I think that's enough to show it blow up. Yeah. It's very rare that you're happy to see an error. It blows up. Why does it blow up? Unbounded local area, local variable account reference before the assignment. What that's telling me is that I've referenced something, but it hasn't been defined yet. I don't know what it is. It's looking for something inside. What I do is I put the name of the class in front of it. And that tells Python, hey, I know, thank you. That tells Python, hey, this is a class variable. And I know the name of the class. I'm defining it. It's animal. So I can tell it, go to animal.account. And add 1 to that. That will say, oh, animal. Okay, you declared that right after the class definition. I'm hip to that. That's fine. So if I rerun, it won't do anything. I get no error. It just runs. Now, for a class variable, we can also do getters and setters. I usually do this after the instance variable, getters and setters. Because we're using it to keep track of deleting and creating objects, just creating right now, I'm going to show you deconstructors in a minute, we really just want to do a getter. So let's say get account and self, and it returns the same as before. We want to put animal in front of it and then account. And if I'm not mistaken, that'll do the trick. So now, if I have this, I can say A1. No, I want to print it. Print A1.getAccount. And when we run it, it'll tell us 1. Because that's how many objects we've created. Now, what's the next thing we're going to do? I think you guessed it already. We are going to jump down here, and we're going to create A2. And A2 is an animal. We'll call him Joe. And Joe will be a little skinnier than fat old Fred. We'll make Joe 100. But now when we get the count this time, what's going to happen? We create our variable name. We say, I want an object. I want you to use the class animal to build it and use Fred and 200 as the parameter. So we go up to animal and we create our object with our constructor. And when we do, the last thing we do is we go to animal.account and we add 1 to it. So that account becomes 1. Then what do? We look for our method getAccount in A1. What is A1? It is an animal object. So we come up here And we look for the method, and hey, look at that, get ACount is there. We return animal.ACount, which in this case now is 1 because we ran the constructor. Boom, and then we have 1. But now we've added 2 lines of code. We've created a new object, A2. This animal is named Joe, and the weight is 100. So we come into the constructor, and we give the instance variable self.name, the name Joe. We give it the weight 100, but we're incrementing the class variable. Currently, that's 1 right now, but we're going to take it and add 1 to it. So now, when we run a1.getCount, I shouldn't do that. It doesn't matter, because every object can run getACount, and it'll give you the same answer because it's looking at the same variable, but I'll run A2 instead of A1. Now I go to A2 and I say getACount. It goes to animal. Drop down the line, get ACount, and it returns animal.ACount, which now is 2, because 2 objects have been created. Let's go see if that's what happens. And that is what happens, 1 and then 2. So even though A1, nothing was done with A1, I created a brand new object, and it increased that class variable, and then I printed that class variable out, so it's 2. So now I have a way to keep track of how many objects have been created. And what's neat about this is, watch this. C1 equals cat. And I will go reinvigorate old Felix. And I'll say brown. Now print C1 dot get ACount. What's going to happen here? This is an interesting little rub. It says 3. So now we have 3 objects. But what happened here? I went to C1 and said cat, Felix, 12, brown. So what happened? I went to the cat class. It inherits from animal. I run the cat class constructor. Name, Felix, weight, 12, color, brown. I run the constructor for the superclass first. So I pass up Felix and 12. When I do that, I run the constructor. What happens when I run the constructor? I give it Felix, I give it 12, but I also click the animal counter. So I'm still increasing that counter, that class variable, even though cat inherited from animal. I'm still keeping track of it there. And because cat inherited from animal, I also have access to the class variables that are defined in class animal. So then when I come down here, I say print C1, get ACount. Well, what's C1? C1 is an object that was created with the cat class, so let's go up to the cat class. All right, get ACount. Let's see, init, color, it's not here. So what does Python do? It goes to the class declaration. It sees the class that it inherited from, and it goes up to animal. And says, is there a get ACount here? There is. So what does it return? It returns the class variable ACount, animal.ACount. And when it does that, you see down here, it produces a 3. So now we have a way to keep track of how many objects we have created. That 3 down there, the last time we got it, there are 3 objects. There's A1, A2, and C1. A1 and A2 are animals, and C1 is a cat, because we're keeping track of animals. We could create class variables for cat and dog. Now, animal wouldn't see it, so we'd want to start from 0 and maintain a new variable, probably called, get cat count. And we could do that. That would take a bunch of time. We're not going to do that. We want to move along. But so that's how class variables work. Class variable is defined outside of the constructor, right after the class definition. And to access it, you use the name of the class dot variable. And you can not only use this for counters, you can also, a lot of times it's used for things that are called flags. If you have a condition like, has the cat been vaccinated? Yes or no, true or false? Well, I can set a class variable that clicks off how many times a vaccinated animal is created or something like that. You can keep track of different flags and different counters and different things with these class variables. They come, believe me, they come in handy to keep track of things when you start getting more sophisticated with your programs. And I just want you to, if you look at an example in January or February after this class is over and you see a variable being defined outside the constructor, I don't want you to go, huh, what? What's going on? Because class variables are used quite a bit, and I want you to see them. Okay? So that's class variables, and that's how we access them and change them and alter them. Now, let's do something. That's my coffee machine beeping. Let's do something a little different. Let's create a method that is the opposite of a constructor. The opposite of a constructor is a thing called a deconstructor. Now, in another language, C++, you have deconstructors, and they, I believe, are just a tilde in front of the name of the constructor. In C++, you can give your constructor names. It's usually the name of the class. And then at the bottom, you'll see tilde, name of the class, and that will be your deconstructor, the instructions to follow when you delete your object. So in this case, definite, the constructor, is the first method you see. Classically, and I usually do things this way, the last method that you will see is the deconstructor. Now, in Python, we had a special name for our constructor, which was dunder and init dunder. We have the same thing for deconstructors, only now it's dunder, del, dunder. The del, as you've probably guessed, stands for delete. We are going to give it itself, and that is it. Now, what do we want to do when we destroy our object? We're going to say animal.account, decrement by 1. So now when we destroy an object, we are going to take our animal counter and decrease it by 1 because we're getting rid of one of our animals, which sounds terrible. It's like we're euthanizing them. So I'm also, just to show it, am going to say print an animal has been deleted. That's the nicest way to say it. And then I'll give that animal's name. And I want to do that. So we will do that. So when we delete an animal, the animal count will be decremented by 1, and then we'll print the animal's name that has been deleted, okay? So we created a deconstructor here, dunder, del, dunder. We have to feed it the self. We feed it the actual name of the variable that's holding the object. We decrease our counter by 1, our class variable, and then I'm just going to print that it's been deleted so we can see it and we can test, okay? Now let's go to the code. I'm going to create an animal, and I'm going to say animal Joe. Joe's 100 pounds. Joe is not fat old Fred. So let's go get fat old Fred. Animal Fred, comma 200. Then let's go get Felix, because Felix is going to feel left out if we don't include him in the proceedings. Felix is brown. And D1. Fido would feel the same way. Fido the red dog. We should call him Clifford the big red dog. So I've created 4 objects using my classes that have been defined above. I'm guessing, and I can do it on any one, D, if I get a count, so yes, idle, I know, I'm going to take care of it, watch. See, now do you feel better? I'm going to print the a count variable and see if it says 4, because I've just created 4 animals, 2 generic animals and a cat and a dog. Let's see what we get. Okay, it prints 4. So I'm in good shape. I know I have 4 objects. But now I want to get rid of one. Let's say Felix has to go. I'm not going to go into detail on this, but Felix has to go. So how do I delete an object? It turns out in Python, there's a keyword, and it's a command for getting rid of an object, taking the memory that it used and putting it back in that big old pile of memory, it's called a heap, where programs get their memory from. And what it is del, del, shock. That's what we actually named the method. And as you can see, it's orange, viva la idle. It took our keyword and made it orange. But what do we want to delete? I'm going to delete C1. I'm going to delete Felix in this case. Okay? So now when I run that command, what's going to happen is I'm deleting C1. What's C1? C1 is a cat class. So I come up here. Cat. Is there a delete method? No, there isn't. But wait, I inherit from animal. Let's go up to animal. Okay, there's animal. Is there a delete method? Yes, there is. What am I going to do? I'm going to decrease the class variable by 1. So it should go from 4 to 3. And then I'm going to print an animal has been deleted, self.name. What is self.name for this object? Felix. So we should see an animal has been deleted and then Felix. And then what we're going to do in the next line is we are going to print our get count again, and it should be decreased. I'm hoping it does anyway. So I've created 4 objects, 2 generic animals, a cat and a dog. I print the class variable, which is keeping track of their creation in their constructors, or the constructor of animal. And when I printed it down here, it said there were 4. But then I'm using the del command to delete an object. And because I've defined a deconstructor to perform some actions as it gets deleted, it should print out that Felix is going the way of the dinosaur, and it'll decrease my class variable a count, and I will check that in this last line. Now you'll notice I can't check it using Felix because Felix is gone. C1 is not going to help me anymore, so I just access the one in D1, Fidos. Okay, let's see what we get. Please work, and it has. You can see we have the 4 objects, but then when I delete C1, which is the object that was Felix, it says an animal has been deleted and it was Felix. And then when I print my class variable, it says now I only have 3. Okay? Now if I wanted to, I could get rid of Fido. And you said, oh, D1 is not defined. Excuse me. Oh, because I used D1 over here. Let's change that. We'll use A1. That's a good little tip right there. Good little thing to see. Remember, when you call in a method inside the class to go get that variable, you better make sure the object you're calling it on exists. Because I just deleted D1 and then I called the method on it. Python tells me no, but I believe if I just use A1, that will fix things that it has. There you have 4. An animal's been deleted Felix, an animal's been deleted Fido, and now I only have 2 left. Now, call me crazy. I also believe if we want to, we can just dispense with our getters and setters, and I can just print that variable. I believe that's the case. Let's find out. And it is. See, I have the 2. Now, you're supposed to do things with getters and setters, but I don't have to do that because it's in memory and I can go grab it anyway. So if I destroy all, let's test this theory. If I destroy all of my objects, so I come down here and I delete A1 and then I delete A2, then you might be saying, well, I don't have any objects left. How am I going to call that method to find out what my count is? Well, that's the way you do it right there. You just access the variable directly. Some people may have had experience with C++ or Java, and there you deal with public classes and private classes and something in the middle called protected classes. We don't really get into that here. There are different ways to do what's called encapsulation, where only certain things can see your data. But here with Python, we make everything public, so I can call animal.aCount and see what it is. If I'm not mistaken, it will say 0. And that's what it is. I created all my animals and printed out the animal count, which was 4. But then I set about deleting them all, and now there are none. So they are all gone. And instead of calling my getter from my class variable, here I had no object left to call. So I just went and got the variable myself. And I did that by saying go to the animal class, dot, and get me the aCount variable and print it. And that's what it did. Okay? Now, something real quick. Let me get my animules back by getting rid of the delete, and then I run things. Hey, I got my animals back. What happens if I just say print Fido D1? What is that going to give me? If I just, like it were a string or an integer, shot my object to the print function. Let's find out. Look at that. That's kind of weird. Now, I think we went over this in the slides. What that is the memory location of the object dog. As you can see, it says dunder main dunder, long story there. We'll go over that some other time. Dot dog object at whatever. If you have an integer and you print it, the actual, it's funny, everything we've been doing so far is really classes. So there's actually a class called integer, and when you get a regular number, it's using a class called integer, and it has a function that it has defined, or a method, I'm sorry, that tells Python what to do if you run the print function on it. So if you run a print function on an integer, it prints the integer. If you do it on a string, it prints the string. If you do it on a list, it shows you the list. So the thing with object is you don't really know from object to object, especially with self-defined objects, what should be printed when we print it. So we are going to look at the very last topic we want to go over, which is overriding functions. Now, you've done it already, but I'm going to show you this one last example because it's kind of neat and it's a good thing to know, is we can tell our classes what to display when print is run on them. So the way we do that, and I usually do this right before my deconstructor, is we will override or write over a function called str or string. Now what string is a function that is defined by what's called the superclass. Every class you create really gets its start from a generic class called the superclass. And superclass has a bunch of defaults defined already. What are those defaults? These dunders. There's a default init, there's a default del, there's a default string, and you will inherit automatically from this big super object if you don't redefine things. That's what's happening here. The default for any object is to just, I don't know, print out where it is in memory. That's something I know I can do for every object that exists. So I can do that. Other programming language will just dump all the data. It'll dump all the instance data out. Other things do other things. We have a setup here where we can define what we want it to do. So I happen to know that the return type for this shock is a string. So what you want to do is create a string. We'll call it a string, and we'll say this object. Actually, we know it's an animal, so I'll say this animal is, and then print the name. But I'm creating a string, so I'm going to concatenate. And I'll just say self.name, and then I return a string. Okay, now I did this in animal. I didn't do it in cat or dog, but because cat and dog both inherit from animal, it'll work with them. So whenever you have a situation like we have where you have a big superclass and then other classes that inherit from it, if you're going to override the string method and create deconstructors, it's a good thing to do that in the top level class. If you don't have to do anything special as far as printing. If we wanted this to say this dog is, then we would override string for class dog, but we're just going to do it with the animal. So I overrode the dunder string dunder method, and I create a string called a string that just says this animal is with the name, and then I return it. So then when I run this command now, print D1, it's going to say D1. What's D1? D1 is an object created with the dog class. It's a dog object. So I come up here, dog. Is there an underscore string? Because that's what print uses. It looks for the dunder string dunder. And no, there isn't. So wait, I inherit from animal. So let's go up to animal. I go to animal. Is there a dunder string dunder? Yes, there is. Now, if it didn't find it, it would have gone to that super Zeus of all classes, the super class, and used that dunder string dunder, which prints the memory. But we're not going to do that anymore. We've defined our own. So we're going to create a string. This animal is self.name. D1 is Fido. So it should say this animal is Fido and in the string, and it returns a string, and that's what gets printed. All right? Cross your fingers. Let's see if it works. And it does. This animal is Fido. Now, the neat thing is, oh, didn't want to do that. Print D1, print C1. Does it for Felix too. Anything that's an animal, it will do it. So now if I send that to the print, it will do whatever my dunder string dunder tells it to do, which in this case is print the animal is and then the name of the animal. Now, this probably gets ugly, but just to find out what happens, I'm going to do comma C1, comma A1, see what that gives me. All right, prints them all in a row. So remember your formatting and remember what you want to do. You might want to throw a \n in there, just in case. Okay, but there you go. There's Fido, there's Felix, and there's Joe. So we're doing the right objects. Okay? Now, do I have time for this? No, I'm running pretty long. I can do one more thing here, and I'm not going to do it for time's sake, but I could take class animal, class cat, and class dog and put it all in another file and call it myAnimals.py, and then use an import statement to, it'll take me a minute, let's see, class animal, class cat, class dog, copy, file, new file, bang, put it all there. Okay, class animal, call that a library for animals. And I will save it in the same file as all those other things, and I'll just call it animals.py. Nothing else is called animals.py. Yeesh. Animals.py. Okay, so in animals.py, I have class declarations for animal, cat, and dog. That's it. No code, no anything. Put it down and get rid of it. Now, up here, I'm going to delete all of that. Uh-oh, I might be in trouble now. So now my program is just this. So what do I want to do? I want to say from animals, import animal, cat, dog. Just like functions and just like constant variables, we can put our classes in our own libraries and put them off to the side and then import them into our programs. So now, I don't need this main anymore. I'm not defining anything above it. Look how small this code is now. Okay? Well, hey, you know what? Why don't we make sure it runs first? Same thing, same behavior, see? And this is more like what you would do in a real setting or a real professional setting. I have the same behavior. Because my classes are all defined, they're off in my animal.py folder where I have all of the definitions done and everything's defined and everything works together. And now I just have to use it in my program. Now what's neat about this is that I get a cat object, and cat, let me go, here we go. Cat inherits from animal, but because animal is above it in the library file, that's fine. And it works perfectly fine. So now all of that code is now in my library. It's there for me to use. I now have, like I did with my function libraries, I now have all of my animal classes in there, and I can use them anytime I want. So I've created, you know, Fido, so I can say D1 dot get weight. And it works. Fido's 30 pounds. There he is. I can use it. So this is the end game. This is more of what we're going for when we do things with classes. We're going to create our classes that we're going to use, and we're going to put them in libraries, and then we're going to have them. And then when I write my program to actually do something, this is what I'm going to do. I'm going to import my classes from my library, and then I'm going to create my objects, and I'm going to use my objects to do what it is I need to do, the reason I wrote the program in the first place. All right? This one's definitely going long because I'm looking down at my clock and it's already 8:30. So I'm going to finish up. This is classes in a nutshell. You've done a lot. I mean, in only 3 weeks, some people get entire courses on object orientation, and they do object orientation over 3 months. They'll learn about classes, and they'll learn about constructors. They'll learn about getters and setters and how to use things and how to model objects and create classes for them like you're going to do with the deck of cards. And then you learn about polymorphism and inheritance and class variables, deconstructors, things along those lines. You're getting it all in 3 weeks. You'll see if you're looking things up on the web and you're curious and you're looking things get a little more complicated than all the stuff we're doing, but we're touching all the big bases. You guys, when you watch this video, engage with the other resources you have and do that programming assignment with the deck of cards, you're going to understand object orientation. This is a 3-week crash course in object orientation. So you're seeing more than the basics here because we're doing some other things. But okay, so I always say it. It's YouTube. Stop the video. I'm going to take this code, animals.py, and u5r3.py, and I'm going to put it in your resource folder. So you're going to have it to look at. Okay? That's it. That is object orientation, a whirlwind tour of object orientation in Python. Announcements. I just did a video 2 nights ago, so you know all the announcements. One thing I'm going to make mention of that I think I forgot to make mention of in the last video is that there is no class this coming Tuesday. That class got bumped a week. So we're not going to meet the Tuesday before Thanksgiving. We're going to meet the Tuesday after Thanksgiving. So remember that, because if you look at the syllabus, I believe it says next Tuesday. It's not. It's pushed a week. Okay? I believe it's December 1st, that Tuesday. So do not get crazy. All right? We don't have class. Grades are coming. If you didn't get them, don't worry about it. Eric is finishing things up, and hopefully tomorrow I will be getting you the Unit 4 grades. So no worries on that, okay? I got email from Charlie, I think, today, who said he wanted to resubmit a program, and he got caught up with I had not gone to Sakai and set the assignments for unlimited submits yet. I will do that when I do all of the stuff tonight, when I upload the link for this video and I go in there and do an announcement and all those things. So I will change that as well. All right? All right. Then you be good. Take all this slow. Read the code. Play around with it. Run it. Change things. See what happens. And I think you're all going to be good, okay? Talk to each other. If you have questions, put things in the forum. All right? And please, 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 please engage with these resources now, because you don't want to do nothing next week, have Thanksgiving, and all of a sudden that Saturday morning when things are due in 3 or 4 days, then start looking at this stuff, because that'll be way too much. You need to engage with all these resources now. I'm probably preaching to the choir, because if you're watching the end of this video, you've probably watched all the other videos and you've done everything already. But tell your friends, tell everybody. Please engage with these resources and get some of this work done now. Because when I create these units, I create them as a 3-week task. I don't create it as, yeah, somebody could whip it together in 4 days. I want you to, the 3-week units are in 3 discernible sections. So I want you to take the first week and do classes. I want you to take the second week and do inheritance and polymorphism. Then I want you to take that third week and do class variables, deconstructors, and overriding functions. Okay? All right. Then you have a good night. Rutgers won today. We beat Army, which is no great shakes. And Army was pretty close at the end of the game. But we ended up winning. But who cares? There's no way they can finish 500. And people are still talking about, well, maybe they'll still go to a bowl game at 5-7. Who wants to go to a bowl game at 5-7? What a bunch of nonsense. All right? You have a good night. And I will be talking to you very soon. Take care now. Bye.